So we've talked about probability, what it means, how it's unpredictable in the short run, predictable in the long run. And we've started some probability rules, like how to find simple probability and how to find the probability of something or something else happening by adding probabilities. And we saw that we could be presented information in a Venn diagram. We could be presented information in a table. Okay, we could be presented information in a probability distribution. So now what we're going to talk about is how do we find the probability of something happening and something else happening. Okay, not just or, but and now. But before that, we wanted to, in order to know that, we have to talk about conditional probability. Okay, and when you talk about a condition, you're talking about the word given. Okay. So we're going to start looking at probabilities of something happening, given that something else has happened. And the notation that we use, remember, we call events when we're calculating probability by capital letters. But this here, this vertical bar, means given. So how would you interpret that notation? P, A, bar, B? Well, you're trying to find the probability of A, given that B has already occurred. And we're back to our OkCupid example that we did in the last lesson, where we broke it down by two variables, two categorical variables, whether they earned more, or whether the men earned more than the median or less, and whether they were taller than the median male height or shorter. And we saw the numbers that we had. We showed it in a Venn diagram like you see here. We can show it in a table like you'll see below. We'll talk about something else, how we can show it a little bit later on in this lesson. But for now, here are the numbers. Okay. So just by looking at this, you can answer a whole bunch of questions. Okay. First of all, remember there are, no, what was the total? 192? Not the total? Yeah. All of them? Yeah. So like I could ask you a bunch of questions that we've already done. What's the probability of selecting a high income earner? What's that? High income earner. Remember, this is tall man, high income earner. 149, but probability has to be a fraction. 149 over 192 is the probability of selecting a tall man, or sorry, a high income earner. Well, there are 48 that are high income earners and short, right? Because they're outside the tall circle. And then there are 101 of them that are high income and tall. So all the high incomes are 149 out of the total number. Gives me 192. What's the probability of selecting a short man? Did you agree? 69. Wouldn't short be everything outside of tall?
It's short.
So these guys must be short. Same with these guys, right? Because these guys are short and they're low income earners. So yes, it would be 69 over 192. Okay. What's the probability of selecting a tall man and high income earner? 101 out of 192, right? Because it's the intersection. They have to be both. Okay, so you can see all the questions you could be asked. So what's the probability of let's answer these questions. What's the probability of selecting a tall man? One what?
123 over
123, it's 22 plus 101 over 192 gives us 123 over 192. Okay. Now this is where you got to be a little careful, because now we're going to go into conditional. What's the probability of selecting a tall man given that they are a high income earner? That's going to change the total. The total is no longer 192. What would it be? The total would be 149. So what's the probability of selecting a tall man given that they're a high income earner? Well, the high income earners are here, right? So it's 101 plus 48 is the total high income earners. But then the ones there are the ones that are tall in H. There's 101 of them. So we get 101 over 149. So really what we did here is we found the probability that they were tall and a high income earner, and we divided by the probability that they were a high income earner. Because if you think about it, probability that they're tall and high income is 101 out of 192. Probability that they're a high income earner is 149 out of 192. Well, we're dividing fractions here, right? So this is the same as 101 out of 192 times 192 out of 149. Those reduce down to 1, and we're left with 101 out of 149. So that's why we can use this formula. So this is an important formula to remember. This is what we use to calculate conditional probability. And you will be given that formula all the time. You don't have to memorize it. So to find the probability of A happening given that B has happened, you find the intersection of A and B, that they both happen, and you divide by just B happening. But we don't have to express them as fractions all the time. We can do it like this. Okay? So what that means is we're always going to divide. Okay? When you find conditional probability, you're going to divide by the given. So you're going to divide by the second letter. Okay. Same numbers, but expressed in a table now. Okay. So it's still the same as this. So the probability of a tall doesn't change, because if you think of tall, we've got 22 here, 101 here, so we've got 123 tall out of 192. Same as there. Okay, we calculate it the same way. We get 123. So using that probability formula for the second one, we would have to find, if we want to find the probability of selecting a tall man, given that they're not high income. So we want to find the probability of tall and low income, which is really what HC means. It means not high income, which means it's low income, divided by the probability of getting low income.
22 over 43.
Right. So tall and low earner, 22 of them, over low earners total, 43. Now, we can test, now that we know conditional probability, we can test whether two events are independent of each other. Okay? And if two events are independent of each other, that means knowing the outcome of one event does not affect the probability the other event will occur. Okay? So before we get into this example, let me give you another example with cards. How many cards are in a deck? 52. Okay? So let's say we're going to do two things. And we're going to draw two cards. So if I said, what's the probability of getting a king? And then what's the probability of getting a red card? Okay. Now, when I say and, that means I have to multiply. But so what's the probability of getting a king? 4 out of 52 or 1 out of 13, right? Okay. So that's happened. You don't put the card back in the deck. What's the probability of getting a red card? You sure? What's that? We have, yes. How many red cards are left? Exactly. Who said that? Depends. It depends on what that first card was. Was it a red king? Right? Because if it was a red king, it changes the probability of the second event, doesn't it? If it's not a red king, well, it still changes the probability of the second event because there's one less card. So instead of out of 52 cards, it's going to be out of 51. So that means those two events, they're not independent of each other. They are dependent. It depends what happens in the first one. However, what if I did the same thing, but after I picked the first card, I put it back in the deck and reshuffled? Now it's independent, right? Because it doesn't matter what happened in the first one, because I still got 52 cards and I still have 26 reds on the second. That's what it means by independent. Now, to calculate independence, and remember, just let me, the probability of A, given that B has occurred, will be the same probability as just A. If that happens, they're independent of each other. If those two probabilities are equal. If they're not equal, that means that this affected this somehow, which is the very definition of not independent. Okay? So we want to find T, and then tall man who was a low income earner would be that. So the probability of selecting a tall man, we found it on the previous page. It was, yeah, I'll actually, it's easier to change it to decimal with these ones. So a tall man was 123 out of 192. I'm just going to go to decimal here, and it was approximately 0.641, because it's easier to compare when with decimal point. The probability of a tall man, given that they are not a high income earner or a low income earner, we calculated on the last page, was 22 out of 43, which works out to approximately 0.512. Okay? These two probabilities are not equal to each other. Therefore, they are not independent. Okay? One of them affects what happens to the other. Right? Because the probability of selecting a tall man is 64%. But the probability of selecting a tall man, given that they're a low income earner, probability goes down. So it's been affected by the fact that they're a low income earner. If this worked out to 0.641, these two would be independent. So we would say because, and this is really all you have to say, because 0.641 does not equal 0.512, these events are not independent. So when you test for independence, okay, you calculate the two probabilities. If they equal, independent. If they don't, not independent. Remember in the last lesson, we talked about mutually exclusive, two events that can't happen at the same time. Like if you roll the die, you can't get a 2 and a 6. You get a 2 or a 6. You can't get a 2 and a 6. So what about independence versus mutually exclusive? Remember, like I said, mutually exclusive when events have no intersection or they both can't occur. So we can see here that these are mutually exclusive events. And what's the probability that A occurs? 0.8. Okay. What's the probability that, now this is where you got to wrap your head around it a little bit. What's the probability that A occurs given that B has occurred? 0. It's nothing. So we can see these two events, they're not independent, but they are mutually exclusive. Okay. So mutually exclusive events are always not independent. No, it's not a huge thing to remember. And knowing that one event occurs greatly affects the probability of the other event, it actually reduces it to 0. I mean, maybe you could think of it, how could I say this? Like if these were two events where this was males and pregnant, and if I said this was 0.4 and this was 0.6, I'd say what's the probability of selecting a male? 0.4. What's the probability of selecting a male given that they're pregnant? And don't start arguing science with me and stuff. Well, technically, I don't know. I'm not up on the latest science. Okay. Okay, so remember when I talked about we have this formula. Find conditional probability. It's the probability that both events happen, that one and the other happens, over the probability that the second one happens. Now, if we do a little algebra, and if I want to figure out this, how do I calculate this? Well, we multiply both sides by the probability of B. Those cancel. So therefore, to find the probability of both events in a situation happening, we take the probability of one of the events multiplied by the probability of the other event, given that the first event has happened. So that's how I went from here to here. Remember, or means add, and means multiply. This is if they're dependent events. Okay? If they're independent, well, then it's just probability of B times probability of A. That's all it is. So like if I said the probability of A is 0.8 and the probability of B is 0.2, and they are independent events, to find the probability of the first one and the second one, I just do 0.8 times 0.2. Okay, last thing I want to talk about. These questions can get a little complicated. Sometimes it's useful to do something, bless you, called a tree diagram. And it helps you sort of see all the probabilities and then be able to answer specific probability questions. So in this situation, we have a 0.65 probability of getting higher than average GPA and ACT scores, which means there's a what probability of getting lower than average. If it's 0.65 higher than average, then it's 0.35 lower than average, right? Okay. So let's start our tree. Higher than average. Lower. And let's put our probabilities in. So we're talking about getting admitted to some university or college in the States. Start doing more units. So stop. If you are higher than average, you have a 0.83 chance of being admitted to this college or university. So there's a branch that comes out from here. You're either admitted or you're not. So the chance of admitted is 0.83 if you have an higher, given that you have a higher than average GPA and ACT. Which means no admission would be what? 0.17. Now we go to the below branch. If you've got a lower than average GPA, it kind of makes sense that you would have less of a chance of being admitted. But there still is a chance. And it's 0.39. Which means the chance of not getting admitted is going to be 1 minus 1 minus 0.39, which gives me 0.61. Okay. So we've got 4 situations here. You're admitted to this place, given that you have a higher than average GPA and ACT. You're not admitted, given that you have a higher than average GPA or ACT. You're admitted, given that you've got a lower than average GPA or ACT, or you're not admitted, given that you have a lower than average GPA or ACT. So what we can do is we can calculate probabilities from here. So the probability that you are higher than average GPA or ACT and you're admitted is 0.65 times 0.83. So it's higher and admitted. Because we multiply the 2 previous branches that led there. And that will give us, I don't know if I have I didn't fill out the numbers. So that would give us 0.65 times 0.83. I'm going to say approximately 0.54. And you can find all the other things. The probability of not getting admitted and having a higher than average GPA, well, would be 0.65 times 0.17. Which gives us approximately 0.11. And then you would find the other ones the same way. 0.35 times 0.39. 0.35 times 0.61. But remember what those mean. Okay? Higher, I'll put these in. higher and no admission, lower and admitted, lower and no admitted. And these ones work out to 0.35 times 0.39 gives us about 0.14. 0.35 times 0.61 gives us about 0.21. Now remember, I approximated these, okay? But tell me, what should all four of these add up to? 1, right? Because there's 4 possible situations in this problem, okay? So these are all going to add up to 1. All right, now that we've got a tree diagram, let's answer some questions. So we're told 2 of the events, getting a higher than average ACT or GPA, and the event of being admitted to your dream school. Okay. Some of them we've actually already calculated. One of them we've already calculated. So what's the probability of higher than average GPA or ACT and you get admitted? 0.54, right? We found that one up here. And just remember it was 0.65 times 0.83. Which was 0.5 for 1. This is why it's useful to have all these numbers, because you got to think about this next one. What's the probability of getting admitted?
0. Or work. Yeah,
You're right. You add them here. Because what's the probability that you're higher and admitted? 0.54. What's the probability? There's another situation where you're admitted. You have a lower, 0.14. So it would be this plus this. Because really it could be higher and admitted or lower and admitted. So in this case, it would be, I'm gonna write it out. 0.65 times 0.3 plus 0.35 times 0.39. And that's going to give us right here 0.68. This next one. What's the probability of having a higher than average GPA ACT given that you've been admitted? Remember that formula. It's the probability of the 2 of them occurring together over the probability of the second one. So what's the probability of them occurring together, hire and admitted? 0.54 divided by 0.68. Because we divide by the probability of getting admitted. And we have, so notice we had to calculate the probability of getting admitted first by adding two probabilities before we could answer this conditional probability question. Okay. And then that's going to give us approximately 0.79. It gets a little challenging when to calculate or to use the multiplication rule when the events are not independent. But just sort of some guidelines you should be familiar with when we're doing probability. So you can always do a Venn diagram, a two-way table, or what we just did here. Remember the complement rule. Remember that OR means add and subtract any double counting, if there is any. Given means divide, and means multiply. But if the events are dependent on each other, you have to adjust for that, like we had to do here. Okay. So really, what this is just about getting exposed to a lot of different problems and figuring out what to do from there. Okay, which is sort of what we're going to spend. Like there's one more lesson in this unit about probability rules, and then we kind of branch off into a separate probability discussion. So really after 5.4 we will have finished all the rules, but it's really important that you stay on top of the exercises, the practice. Okay, because if you leave all of those blank and don't do them, it's going to get really confusing real quick.